Hello and welcome back to a new video here on the Lötwig Fusel channel to another Unreal Engine 5 video. A few things are going to change this video from a technical standpoint because, well, the Unreal Engine should be scaled a bit more up so that you can see things better, and I have a new microphone which is actually like at least a decade older than the microphone that I had first. Ideally this shouldn't give you any changes in quality, but at least for me in editing and with audio levels, because now I should have enough headroom to talk. Let's hope this is all working. I need a new pop thing as well, but yeah. Alright, so previously we always started the Unreal Engine by opening up the Epic Games Launcher. We're not going to do this from now on. This has one main reason. As soon as you get into starting writing your own classes for the Unreal Engine, you are actually going to have some issues with your just using the live coding feature of Unreal Engine. So basically inside of Unreal Engine there is a button which basically says recompile code and load it in. And if you're just using that button, you might have some issues when you restart the engine because the code has never been really compiled correctly. So every time you want to do something with C++, if you're just like a level designer and not touching C++ at all, you can leave this all to your developers who are writing code in C++. If they supply you the correct binaries, everything is good. But if you're a C++ programmer, you want to make sure that your code is always up to date and compiled correctly. How are we going to do this? Well, of course, we're going to now start by opening a Visual Studio. It's just like everybody who develops software. And as you can see, we have here our project. As soon as we open this once during the by engine created project. So basically you create a project using the Epic Games Launcher and the Unreal Engine Launcher, then you close it up, or you not close it up, you first make sure that the solution was opened once, and as soon as you close it up, it's going to be registered in the project browser of Visual Studio. I'm going to click it here, new CPP tutorial, and it's going to open up the project in Visual Studio, of course on a different monitor as always. And if I now bring this up and scale it up so that you can see it, you can actually see that we have a full instance of Visual Studio with all of our game code. So we have this module here and the stuff we talked about last video. So the next thing that you want to do is we want to actually start the Unreal Engine from Visual Studio. How does that work? So first of all, you want to make sure to be in the right configuration. You want to select either Debug Game Editor or Development Editor. I would recommend going for Development Editor. So basically, Development Editor is a build that contains the Unreal Engine editor, but also your custom code. And now you would be tempted to press F5 or click local Windows debugger, but if you are not want to do some debugging and want to have the engine detached from Visual Studio, because, well, Visual Studio is working a bit better when your code, when there is no process running. So you want to make sure to actually click the right button here. So start without debugging or press Ctrl F5. So I'm going to press Ctrl F5 here to start building. And you can see that it actually builds the Unreal Engine solution and also the new Unreal Engine in. And you can actually see the Unreal Editor is now actually starting up. So everything is working as intended, but we have started it through Visual Studio. And by doing this through Visual Studio, we just make sure that the latest C++ code is available. If it might not be available and you still have some objects that reference that code, these objects are going to screw it up and everything is going to be dead. And that's what we don't want. Next thing that I'm going to do is I'm going to go here into my widget reflector and scale up my my Unreal Engine UI so that you can see the things a bit better during the video. Alright, so here we are inside the Unreal Engine. Last video we talked a bit on how we can navigate around the viewport and how this is all built up, how our solution looks and how everything goes on. Today we actually want to talk about the three important concepts of the Unreal Engine. Unreal Engine objects, actors, and components. And after that, we're going to implement our own component. So let's get started. So first of all, to get to the concept of objects, components, actors, we first need to observe what we got here. So basically what we can see here is our three-dimensional scene that we have created. If I'm going to switch to the outliner, you can actually see all the items that are in here. And as you can see, we have like this audio thing here. We have this what looks like a light, this gamepad with the flag, the floor here, the table, the chairs, these spheres, the background here. So there's another light here. So there are many things that are inside of this world. And everything that is inside the world is called an actor. So an actor is basically and it's kind of like a container for some game associated, let's call it primitive data instance, whatever you want to call it. So everything that you can see in the scene is an actor. Everything here on the right is an actor. Start, background cue, player start, light source, skylight, sphere, reflection capture 10, atmospheric fog, BP, sky, sphere, chair, floor, table. These are all actors. And if I'm going to click on the details panel, you can actually see how the actor is built up. So for example, here you can see the actor that I have currently clicked is a so-called table. It is called table, and it is of the class static mesh actor. And this static mesh actor is just the default actor implementation that the Unreal Engine supplies. We can also supply our own implementation for these actors, but we're going to get to this in, I think, the next video. So as you can see, here at the top we have the actor table instance. It's an instance of the table class, and it's also called table. If I would click in here, I could actually call this table lol, because this is just a name. You can see it's going to be reflected down here. Interesting, but yeah, I can change the name here, and it's basically just a visual representation so that you can find it a bit easier. So table is an actor. By default, an actor is doing nothing. An actor is just an empty container that does nothing. So if we just would have actors, you would see a completely black screen here, because we would have nothing in here. Can I simulate this? Yeah, that is what you would get if you just have actors in your scene. Nothing. The actual appearances, like the sky, the meshes of the table, the meshes of the chairs, the mesh of the player start here, the actual volumetric fog and everything that is in here is actually coming from so-called components. So the actor, in this case with the table, is an empty container. But inside of these container you have components. In the case of the table, there is a static mesh component in here, and the static mesh component is doing nothing more than rendering an object. So basically the static mesh component kind of like talks to the renderer of the Unreal Engine and tells the renderer, hey, I have a mesh attached to me, it's that mesh with that material, and then the renderer basically knows, alright, that is how I can render this. It is actually a lot more. You can see we have physics attached to this as well. So I could like go in and say, alright, simulate physics, give it a mass, 30 kilogram, for example. And then I could like go in, move this up a bit, and if I would start play, boom, the table is falling down because now physics is simulated. So basically, it's a bit more than just the static mesh, but you get the point. It's like a component, and everything that is associated with a mesh is kind of like in this static mesh component. In this case, like the transform, the actual mesh used, the material, physics, collision, lighting, rendering, level of detail, navigation, texturing, custom tags, and many, many more stuff. So basically everything that you might want to use with a mesh is basically included in this static mesh component, and that static mesh component is talking to the Unreal Engine subsystem, so basically telling them how to handle it. Yeah, what could we now do with this concept? Well, this concept is actually quite powerful. We could go in and create our own actor. So let's go to the starter content. Let's go to, no, I think it's not in blueprints, it's in props. And if we would scroll down a bit, we could, for example, find this SM statue. This SM statue is just a static mesh, and as soon as I'm dragging in a static mesh in the Unreal Engine will automatically create an actor on the fly, which just has a static mesh component on it. So this is basically created on the fly, this actor. It's a special type of actor that is built for showing up static meshes. So the class here is the static mesh actor defined in C++. I could like click on this and also would get the source file in Visual Studio. So if I would now go in here, you can see that the static mesh actor has been opened up in the Visual Studio solution. I could go in and see how this is implemented, but that's not the point of the video today. So what can we now do with this concept of actors and components? Well, actually we can attach more components than just this static mesh component to this actor. First of all, let me scale the statue a bit up so that's a bit more visible. Now I could like go in and try to add some more components to it. And as you can see, we have this add button here, which allows us to add any component you might want to have. You can see there are many of them available here that you might want to use. But in my case here, I want to use an arrow component. This arrow component is just like a vector that is pointing somewhere. So as you can see now, we have the static mesh component that under that static mesh component, we have that error. Why is that error under the static mesh component? Well, it's actually quite easy because this is all hierarchical. You can see that the static mesh component has a location of 124, minus 136, and 32. And since the static mesh component is kind of like the root component, so the top level component of the actor, this is actually in world space. So this is the location inside of our three-dimensional world. But if you now go down to the error, you can see that the location is 0, 0, 0. But it is still at the same origin. Like, it's not the tip of the vector that counts, it's actually the origin of the vector that counts here, or the error that counts. The location now is 0, 0, 0, which is actually would be in our scene somewhere different. It's I don't know where the origin is, but definitely not there. We could see this, like, if I would go in here and change this one to 0, there is the origin. So you would think that the vector is actually also at this position, but no, it's at 0, 0, 0. Why is that? Because it is parented under the static mesh component. So it's a child of the static mesh component. So its position is relative to the static mesh component, and the relative position in this case is 0 because, well, it's at the same root where our object is. Of course, we can go in and modify this. So first of all, I want the vector pointing up. As long as I have it selected here on the right in the details panel, the actual controls here are modifying the relative position in this case. So now I have basically rotated it up, so I have a 90-degree angle here, which is relative to my statue. If I now would click the statue again, so either here, the static mesh component, or I just click on it in the scene again. If I would now start to rotate, you can actually see the vector. It's called arrow, but I like to call it vector because it is actually a vector. The vector is kind of like rotating with the statue. I just rotate the statue, and the vector will always do the same rotation because it's a child of the static mesh component. Now I could also go in and say, all right, I want to have this at the top of my static mesh. Could like dial this in a bit. You need to be careful. It is sometimes working if you click the arrow here, but now, as you can see, I cannot select it because it's not the mesh. And if I select it, I need to make sure to go on the right and click it again so that I really can modify it. Now let me actually dial this in a bit so that it looks promising. I just want to have it at the tip. Why? Because I want to have it there to show you something. And yeah, now as you can see, I have put the vector on the top of the statue. Why would you use some of these vector? Well, it's a bit more advanced. You're going to probably have this later on. You can, inside of C++ or Blueprint code, you can kind of like search for a vector component or a vector component with a name, and then you can get its position. So you could kind of like mark a like spawn location or a location where something should go on spawned, or if you have like an infinite runner, you can have several tiles of your infinite runner level, and at each tile there is like an error component where the next tile should spawn, and then basically just search for the next tile, and there you can spawn the new tile. And then you can have like an infinite runner which also has some odd tiles that kind of like do odd degrees of rotation and stuff like that. So basically, it's just a helper though that you can get some position information, and you can also easily visualize this in the editor because like your designers, level designers, game designers, puzzle designers, it's very easy for them to understand the concept of an error. They see, okay, I need to put an error and then name it, and you need to name it like that, and then okay, automatically the code will adapt to that, and basically the error is placeable and changeable, of course, as well. Alright, so what we want to do now is we want to add some audio to that statue. So let's add another component. I want to have some audio, and you can see it's already there under common. Let's add some audio. Let's just call it audio. It's okay. And now I can like go in and select a sound. Let me quickly do this. I want to have some fire sound here. 0.2, that's not too loud. And as you can see, actually the audio component is somewhere down here on the foot of the statue. And as you can see, yeah, it's also relative. If I change the position, let me do this here, that's a bit better. If I change the position, it's also changing relative. And as you can see, yeah, now it's at the foot. But I might want to use that vector up here, or that arrow up here, to maybe spawn some particles, because like the fire that the statue is like burning on the top. And of course, then I also want to have the audio source on the top, and that's actually no problem. As you can see currently, we have the static mesh component, and under the static mesh component, we have the arrow and audio both on the same level. But what I could do, of course, is drag the audio to the arrow. So basically say, hey, audio, no, you are now a child of the arrow. And you can see as soon as I do this, it should, in theory, magically go up there, but it's not, because Unreal Engine is recomputing the new relative position and try to keep its location. But if I would go in here and change these coordinates to 0, you can actually see that now the sound source has been placed at the position of the arrow, and you can actually see that the position of the arrow is starting at 0. It's just pointing where it goes, but the origin, the position you're defining, is always at the start of the arrow. So now I could like put this audio up here, and if I would now hit play, you can see we have the statue, and you can also hear it burning. It's very nice. Okay, that's working. That's all good. That's the concept of actors and components. But let's now maybe go in and define our own component, because we want to make the statue move left and right or up and down or whatever. The statue shall be moving. How can we do this? Well, of course, you can do this all in blueprints in the Unreal Engine, but we are here for C++, so we want to do it also in C++. So move the statue around. How do we do this? Well, we could like write our own actor and move its position, but is that really applicable? Do we really want to write a full static object that is a statue that is moving? You might want to do this, but it's actually not that useful, because moving is just like a property that could apply to anything. So you could move a chair, you could move a statue, you could move a light, you could move everything you like. Why would you go in and basically hardcode this just for a statue? And this is where again the concept of components come in. So actually we can write our own custom component that is changing its relative location to a user-defined value. So basically, maybe if you do some linear motion, it's basically just going left, right, or whatever. And you could basically do this by writing an own component that has a start position and an end position. And then you basically interpolate between the start and end position during time. And because we have this hierarchical component system here, we could basically put this at the topmost level of our actor, and then it would move all of the child components as well. So this is why components are powerful, and this is why we're going to use components. How do we do this? Well, we could like go in here down to C++ classes, new CPP tutorial, and click write and say new C++ class. Or you could go in and say tools, new C++ class. And now you are presented with that window that looks total odd, because it's not built to work with the UI scaling. So I need to actually scroll out a bit to see what's going on here. So the add C++ class wizard is basically just helping you creating any kind of C++ class that you want. If you click on all classes, you can actually see that we have 3,874 items available. So this is kind of like every class that is inside the Unreal Engine. You can overwrite everything you want, and you can then patch them in the Unreal Engine and modify the default behavior. So that's actually quite nice, but that's also very advanced. And also you probably don't want to, do you really want to override your own loudness analyzer? Maybe, but it's actually not that common to do that. So because of that, we also have this comment tab, which is the most common classes that we're going to use, and we're also going to talk about all of them. So by default, you can create like an empty C++ class. That's not what we want. We could create a character or a pawn. These are special type of actors that we're going to talk in a separate video. We can create our own vector, but because we don't want to do this, we want to not hard code an object. We want to make it modular as a component. So we're also not going to change actor. And now we are getting to the things. Actor component. Now you attend and see, all right, actor component, I found what I want to have. You could click next and create a class, and then you would write your program, and already in code you would be a bit wondering why there are no functions to actually get the location and stuff like that. This is actually because there are two types of components. We just talked about the one type, that is the most common one, which is actually called a scene component. A scene component is the same than a normal component, but the scene component can be placed in this hierarchical order. A normal component does not have any position. It is just a common component. If you would add this to the hierarchy of an object, so let me maybe select where do we have it, SM statue, there it is. So if we basically would add this, it would be added below this separator line. So this separator line is separating the hierarchical components and the kind of like static components. The static components are not in a hierarchical order, and they are mostly just used to add some functionality. It might have an internal state, but it's not like requiring an actual transform on the three-dimensional world. You could, for example, see this if you have like a billboard on your game that shall show an image from the internet. That this may be a banner for some ads, and you want to change these ads in your game so that your latest new game is advertised in your old game. If you have like a Mirror's Edge type of game and you have a city where the people run around and you have these ad billboards that are around the city, you could then kind of like have a web API where several of these ad graphics are stored on the internet, and then you could dynamically change them out to maybe advertise like a new game, or also make a bit of variation in the game so the ads are actually changing. Could do this if you want. And if you would do something like that, you could basically write your own component that is just responsible for fetching the image from the internet, but not displaying it. So just where you have like your URL to your API and maybe your authentication keys, you could all put this into a static component, and the static component would just have a function like get add image, and then it would kind of like return an Unreal Engine image type that already has been downloaded, or it's automatically downloaded on the fly and supplied to the calling function. And then you would do this like with this static actor component, because it's just responsible for getting some data. It's not really doing something on the world. It's just like a helper that is there. But if you want to do something on the world, you need the scene component. This scene component is always placed here on the right in this hierarchy. Like the static mesh component is a scene component, the arrow is a scene component, and audio is a scene component, because it's all having a transform. So scene component would be here the choice that we want to do, because we want to actually put this on the scene somewhere. I'm gonna quickly scroll a bit down so that you can see what's also going on here. Here a few other things like player camera manager, player controller, game mode base, world settings, HUD, player state, game state, blueprint function library, slate widgets, widget styles. These are all like special objects that we might also talk about in the future, or probably going to talk about some of them at least in the future. These are just different things like for HUD display, widgets that are shown on the screen, game states, player states, world settings, and whatever. These are just like also special classes that are quite common. Another thing that I want to talk about is the Unreal interface. This is just like a C++ interface, but it's basically adding all the Unreal reflection and gloriness to that. So there's actually a function where you can ask any Unreal object or an actor or a component. You can basically ask it, hey, do you implement the interface? And then it says, yes, I'm an interface. And this just works because we have this Unreal interface which is adding these meta information so that we can query it. In Java, you would have something like instance of or implements and stuff like that. It's a bit easier to do this also in the Unreal Engine because it has a few more features on top of C++. It's not on top of C++, but it's kind of like having the helper structures to build this around C++. You can always do this like your own with C++ magic, but it's not really intended to do this on your own. So you want to definitely use the Unreal Engine interfaces and classes like that. Alright, so I already told you we want to create a component, and since we need a transform, we're going to create a scene component. So I'm going to select scene component here. I'm going to click next here, and now we have another nicely UI that this was not intended to be scaled. And what I basically have here is I would have a name here. And in this case, we want to move it. So we're going to have a move scene component. I'm just gonna call the scene component here because move is like a very short name. Or move. I'm just gonna call it move component. There we go. And then I can hit create class, and it's gonna create the class and automatically opening this up in the Visual Studio. And you can also see like Unreal Engine has like opened up this live coding window here because it's like live patching the new created class. It's gonna reload them in the engine itself. Can always close this up, you don't need this. Visual Studio is gonna ask you that the file modification is deleted, and now there are two things that you can do. You can click on reload all. I would recommend this. If you have started the project through the debugger, you cannot click reload all because reloading is only working when you're not in debug, and you would need to stop debugging for that, or you could just click ignore all and just go on here. You don't need to reload it. But I'm gonna click on reload because I want to have it in the Solution Explorer as well. So here we go. Now we have the move component.h and we have the move component.cpp. And let's actually take a look at these functions, or these files. So first of all, let's take a look and verify what's going on in the move component.h. So pragma ones, yeah, that we know that. Some includes, yeah, we might not know these, but yeah, they're just including something. Core minimal is including like the core of the engine. Component scene component is the base class that is included here. And then we have the first special thing, include movement component generated.h. This should always be the last include that you write. This is just because this is containing some. Can I go to the document? Yeah, this is basically just some information that has been automatically generated. That basically adds all the reflection information to your own class. If you are changing something, this is actually changed every time you compile. Every time you compile, the Unreal header tool kind of like inspects your header and then adapts these generated files so that all the reflection and exporting of your custom Unreal Engine function gets generated automatically. So this is very important. You don't change this and you always include this last. Alright, the next thing that we have is a class declaration. It's actually two-line class declaration. Why it is that? Because we first have a specification of the class. This uClass macro here with these parameters inside of here is actually telling the Unreal Engine header tool and the Unreal Engine itself how this class works. You can actually change something here. You could like add this is like a class group. I don't know if this is a free text that you can actually put here. We could like you look this up. I think it's actually a free text that you can change. This is basically the group where you can basically find this. So if I would maybe open up uClass here, is that the right one? No, that's not the right one. I'm actually looking for that macro class specifiers. That is what we want. So uClass specifiers are basically the specifiers that you can put inside of this macro to basically tell the Unreal Engine how this works. So we could scroll a bit down. Yeah, I could add like dependencies, deprecated. Do we have what was the show categories? No, class group was that what I was looking for. Class group, there it is, group name. It indicates that Unreal Engine's active browser should include this class and any subclasses of this class specified within group name. So yeah, we can actually change this. Let's actually change this so that we can see what's going on. I could like change this to, how did I call this? New CPP tutorial. Something like that. Should work. Or at least I hope it works, but it should. Basically just another group where we can put it in. It might not work. Let's quickly see. We can actually see if this works by going back to the Unreal Engine and hitting this. Actually, first zoom in again that you can see it. And basically you can recompile your code by clicking on this button here, recompiles and reloads C++ code for game systems on the fly. Let's see if we can actually change this to a free name that we want to have. Yeah, it actually works. It succeeded here. And basically now our component is already in here. We could like try and add it already. Let's click on that one, add it again. And if we would now scroll a bit down here, we're gonna at some point should find our new CPP tutorial. Yeah, that you can see basically this move down here. This is now under the new CPP tutorial, and new CPP tutorial is basically our category that we just specified. So you can put like all of your components inside of your own categories just to order this a bit better here. So I could basically add my move in here. Now we have an instance of move. Yay, that was fine. Very easily done. Could like try to make it as a super parent one and parent everything else under the move here. However you desire. Just add this move component here. And yeah, now we can go in and build this or write some code for that. But actually we have not moved through the class declaration. So what's going on here in the class declaration instead of these like all uClass metadata? Well, of course we define the class. It's a new CPP tutorial API, which just depends on how you're building your project. In this case, it's a DLL export. It's auto-generated by Unreal Engine, so we don't care about that. We have the move component here, the name of the class. We have the base class, which is the USC component. We have this generate body macro. This is important. I think it's inside of this generated header here. Yeah, it is for sure, I think. And basically what this is doing is it's generating everything that is required for this, like expands to whatever. So basically the body that's always required for any class in Unreal Engine is automatically generated with that macro here. All right, now we are coming to the 3 by default generated functions. We have the constructor, the begin play event, and the tick component event. So first of all, let's talk about the constructor. The constructor is used to set up a template of the object. One very important information for Unreal Engine is that you shall never do instance-dependent stuff in the constructor, because it's not guaranteed that the constructor is called for each instance of your object. This might seem odd, but it is like that. Basically, this is used by the Unreal Engine to optimize stuff. So by default, you're basically constructing your component inside of the constructor. And this is kind of like creating a static templateable object. Later on, the Unreal Engine can just go in and hard copy your objects. It's not a real hard copy because it's definitely, I think, a deep copy, but it's not at least always calling the full constructor and constructing everything on the fly. It can kind of like optimize this a bit, and we don't actually care how this works internally. We just care about everything that we want to do in here shall just be done on a per class base, not on a per instance, per object base. This is just the information you should take away from that. Everything else, we don't care what's really going on there. What can we do here, or what we are currently doing in here, is we are defining if the component can be ticked. So basically, one of the superclasses has this primary component tick object inside of it, and this object, which is definitely or probably a struct if I would inspect this, if I would peek in here, yeah, struct f actor component tick function, primary component tick. Right, this is like a struct. And this struct has a member b can ever tick. And it's a Boolean value that indicates if this component can be ticked. What means ticking a component? Well, basically by default, the Unreal Engine will only call functions of your object when certain events are triggered, like begin play when the level starts playing, or any other events. They are basically just fired when this event has kind of like occurred. So by default, the object is just called in certain cases. But it is really helpful, and most of the time also needed for your functionality, to have periodical calls to your objects. And this is called a tick, because it's basically a tick that is sent around all objects. If you have many objects, the tick might take longer. If you have fewer objects, it might be faster. So basically the tick is just like, think there's also a thing that is like in Minecraft, on a Minecraft server, a tick is kind of like one circle that updates every object in your level, in your world, whatever. All your players, all your objects, they are all updated in one tick of your system. And yeah, by default you can actually see that can ever tick it through true. And what this basically means is that this tick function is valid and can be called. You can actually tell the engine dynamically on runtime, hey, stop ticking this object, restart ticking this object. So you can basically switch this on and off dynamically during runtime. But you can only do this when this is true. If you have like a component that never needs ticking, for example, like the example which basically loads the billboard from the internet, this doesn't need ticking. So we can actually set this to false, and then the Unreal Engine can optimize this away. You don't need to do this. It's already stated here that you don't need to do this, but you should maybe consider this when you are having performance issues, or if you want to try to build a robust implementation. Alright, so this is the constructor. Now talking about the next two functions. Well, actually they are already self-explaining because of what I already told you. Begin play is an event, which is coming from, I think it's actually coming from the OptDU object itself. I'm not quite sure. Where is this defined? Begin play. UActor component. It's defined by the component begin play. So basically the begin play event is called when the level has fully loaded and the player kind of like starts entering the level. This is the when begin play is called. It's just event like anything else. There are more events. You can take a look at the Unreal Engine documentation, and we might also talk a bit about more events in the future, but it's just like a begin play event, and you can kind of like, for now, treat this as the constructor of an instance. It is really not, because it's the begin play event, and if you want to have a constructor, there are other events that are way better to use it, but by default we're just going to use that just for simplifications for now. Alright, so the last function that's automatically generated is the tick component function. This is the periodically called function. It has a few more parameters than the other ones. Well, they had none. This function had 3. And basically what it's going to get is the delta time. So the delta time that has elapsed since the last tick. And it's also, or not the last tick, but the delta time of the current tick, because, well, I think as far as I know, every tick function gets the same delta time. It's just kind of like this one tick of the level, basically. It also has this tick type, and this tick type is basically, we could take a look at this, what could be inside of here. Can we do this? Yeah. No, let's not do this like that. We can actually peek in here. So what tick types do we have? Time only, level tick all, pause tick, viewports only. So there are some things in here that you might want to consider. Update the level time only, update time and viewports, update all, delta time is 0, we are pause, components don't tick. So there are several events that might be fired here. So that's something you might want to consider in taking a look at this. All right. What are we doing here by default? We are always calling the super function. Now you would say, hey, super, why is there super? Nobody knows super. This C++, we don't have super. Yeah, but it's actually inside of this generate body. This generate body actually defines super somewhere. We could like peek in here and peek down. I don't know if we're actually getting to something. No, we are not getting into something because this is like generated and we are in the wrong header here. But basically this macro is basically defining the super. All right, so quite a lot of information. Now let's actually go in and see what we can do. So basically we want to define a start and an end position. Well, we already have a start position because each component has a location, a relative location. But we also want to have a relative kind of like end location. We want to have a relative start location and a relative end location. So first of all, we're going to define them as private members. So the type that we are searching for is an F vector that is kind of like a position inside of the screen. And what we're going to have is the start relative location. And we're also going to have a end relative location. And what we're going to do is we're going to interpolate between these two. And we're basically going to have position inside of these two. So let's start by setting the start relative location. So the start relative location should be equal to the relative location of the component. And we're going to do this in the begin play event for now. So we're going to set start location. And what we want to do here is we basically want to assign this. So the start relative location is going to be equal to something called on this object. We're going to remove the sys in a second, but I'm just going to type in sys here because if you don't know Unreal Engine, it's actually quite easy to just type this and you're just going to get functions that are for this object. Well, what do we want to get? We want to get the relative location. So let's see, get relative location. Yeah, the function is already there. So very easy, get relative location, done. So now we have the relative location. So now what we need, we want to have the end relative location. And for now, I'm just going to hardcode this. I'm just going to hardcode this to get the start relative location. And what we basically want to do, can we actually... yeah, let's do this like that. And basically what I'm going to do is I'm just going to increment the z-axis by maybe 100.float. This is just hard-coded for now, but we're gonna make this one fancy in a sec. But I just want to have it set to the 100 float for you that we can see that everything works. And what we're gonna do in the tick component, function here is, of course, we want to compute and set current location. And the current location lies somewhere between the start relative location and the end relative location. But for now, we actually just wanna set this to the end relative location hard-coded. How are we gonna do this? We're gonna do this by basically just calling the set relative location function, get relative location, set relative location, and we're just gonna set this to the end relative location for now, just to hard-code this and to see that it works. All right. So what we're gonna do? Save this, go back to the Unreal Engine. Hit the reload button, it's going to recompile the code. We're going to hope that nothing blows up. And yeah, successfully linked patches and live coding succeeded. So now our code is in here, and you can also see that the move component is also in here in the hierarchy. So let's start and see what it's doing. And it's not moving. Well, why is that? Actually, if you inspect our hierarchy, it's quite certain why it's not moving. The static mesh component is currently the root component. The move component is under the static mesh component, so we are just currently moving the audio and the arrow. Can we verify this? Yes, we can. We can start in here, tap out of that with Shift F1, go to the outline, select our SM statue, go to the details panel, go to the move component, and we can actually see the relative location on the Z coordinate has been set to 100. Initially it was at 0, 0, 0, and now it is at 0, 0, 100. So our code is actually working, but it's not doing stuff because, yeah. The mesh, well, it's actually doing stuff. Actually, the audio should be most loud somewhere here. Yeah, I hear it on the right now, and it's a bit quieter if I go down here. So this kind of works, but well, we actually want to have the move as a parent, but we cannot do this because the root component is written inside of C++, and since this is kind of like in C++, we cannot change this. Now what we actually need to do if we want to do this, we need to create our own class, or our own actor class. We could do this like all in C++ and write this fancy, but actually do we want to do this? No, we don't want to do this, because the move component is something that we have written in C++, where our C++ developers' intelligence sits inside of it. And we basically have written this component so that a game designer or level designer can take this component, don't care about the implementation, and reuse this to throw around in their own levels and stuff like that. And thus, we don't want to write this in C++. We want to have this as a modular component that everybody can use that works on our team. And how can they use that? Well, the designers love blueprints because it's very easy. It's all inside the editor. They don't need to code. And so what they're going to do is they're going to create a new blueprint class. So I'm just going to go into this content folder here, and I'm going to right click, select blueprint class, select actor, and I'm going to call this my statue. Okay, done. Now I can double click it to open it, and it's going to open up here. It might be undocked, something like that here. And if it is like that, you can just drag it in here to dock it basically. And now we have an empty world here. Let me quickly decrease the camera speed so that I'm not like flying around. Now we have an empty world here. It's an empty kind of like, yeah, object. And you can see that there's a default scene root, and that we also have a components tab, we have a blueprints tab, and we have details panels, everything that we know. We also have like blueprint code, but we're not going to use blueprint code yet. And the only thing that we're going to do is we're going to add some more components here. So we want to have our move component. Let's search for move. Here it is, new CPP tutorial, move. Okay, move, enter. As you can see, now it is a child of the default scene root. That's not what we want. We want to have the move as the root. We can just drag and drop this on top of the default scene root, and there we have it. Move is now our topmost component. And now we can start by adding subcomponents. We could add a static mesh down here, static mesh. We could go down here and add the arrow again, and below that arrow we could go in and add the audio component here, audio. There it is. We could go into the audio, select our fire sound again. Could scale down the volume again. We could go to our static mesh. We can select our SM statue again. We can, oh, the materials are already assigned. That's good. We can scale this maybe up a bit. Yeah, let's scale this up by 2. By the way, if this lock is not enabled, you basically can scale this ununiformly, and as soon as you basically enable this lock here, you scale it uniform. So let's scale this like that, make this twice as big, and then we can like go in, click the arrow, and boom, rotate it, bring it back up, and you can see like the audio is moving with it. That's exactly what we want. And we can now basically dial this arrow in to be at the exact position we like that, so that we basically replicated what we had before. We now have the move component, and under the move component we have the static mesh and the arrow, and under the arrow we have the audio component. So we have all that nice hierarchy that we had before created inside the actual world viewport. We now have this as a blueprint. To make sure that everything works, you're going to hit compile up here to compile the blueprint, and boom, it is done, compiled, and ready to use. Now we can go back into our world. We can get rid of the old statue. We can now open up the content drawer again, maybe zoom out a bit, take the my statue, put it in, and you can see it has the right size, the audio is correctly attached, the arrow is attached, and if I now would hit begin play, boom, it elevated itself up 100 units, because now the move component is the root component and it basically jumped up. Okay, good. That's all up and working. Now let's go back to C++ and start writing code. So first of all, this end location shall not be hard-coded. We want to have this as a parameter. And for that, I'm going to actually delete all of that. So I want to actually have this as a parameter that we can personally set. And actually, let me put this back in again. We're going to have it later on. Set start location and set end location. And basically what I want to do is I want to set them dynamically. So basically these are the computed locations. Between them we want to interpolate. We might change them later on, but that's okay. These are the computed locations. Now what we actually want to have is we want to have a parameter. So we want to have a parameter, and that parameter shall also be an f vector, and this actually shall show the move offset. Let's call this move offset. We want to have a vector that is basically defining how far we want to offset from there. And actually we don't want to hardcode this. We want to set this in the editor. And actually it's very nice. We can set this in the editor without any issues. There is a U property, a macro like this U class, that basically defines where we can edit this. So let's add this U property brackets, and then we can basically specify where we can maybe access that, or how this is going to be grouped, how the name of the category is, and many more stuff. You can, if you take a look at this, you're going to have a similar documentation than the U class specifiers. I think this is maybe down here. Yeah, property specifiers. So U property, you can define many things down here. We can scroll down here. You can also put them in enums. You can have them blueprint assignable, blueprint callable for I think functions, edit default, edit anywhere, edit instance only, localized, no export, everything you might want to have. You can read the descriptions down here. You can add meta tags like clamping min max, content directory, display after, display name, display priority, subnails, everything you might want to have. There are so many things. You can basically dial this in exactly how you want to have it. Hide alpha channels for color, for example. Anything that you might have. But what we actually care about is we care about edit. And we care about actually edit of 3 parameters: edit anywhere, edit defaults only, and edit instance only. Edit anywhere basically means that you can edit them in the defaults panel and in the instance panel. And the other ones mean that you can only edit them in the defaults panel or in the instance panel. I'm going to show you what these are in a sec as soon as we get edit anywhere done. For this case, we also want to use edit anywhere, and then I'm going to later show you which panels they are and how this would affect changing this label to edit instance only or edit default only. So let's put edit everywhere in here. And let's now also go in and do this. So by default, we just want to copy the end relative location. We want to just set this to the start relative location. But what I then want to do is I actually want to offset this to the move offset. This is now then correctly computing as the end relative location and also the start relative location. And basically, what we now can basically do is we could basically use this to interpolate between of them, but actually, as you can see, interpolating between an offset and the relative location is actually not that good. So actually, I'm going to completely delete the end relative location here, because we're just going to use the start and the offset to offset vectors. And by that, we also don't need that. This is going to be down in the implementation a lot simpler, because we then can basically take the start relative location and just add the move offset on top of that, and then we are basically at the most extreme. I'm actually going to show you that we're going to then also later on normalize the vector before and after that, before we're going to get the lengths and stuff, but you're going to see this in a second, what we're going to do here. This is going to be a quite smart implementation actually. So now let's go back to the Unreal Engine. Let's quickly hit the recompile button to get the latest code in here. Let's see if we maybe get a crash today, but yeah. Actually, it's working quite fine today. All right, so now we have repatched our code, and if we would now go back into the my statue and click on the move component and look at the right, you can actually find that we have the move offset down here and now at the move component panel. So the move offset that we just defined in C++ is now exposed here with X, Y, and Z. And we could now maybe go in and say, all right, we want to have an offset of 200 in the Z value. Or we might actually want to move this diagonal, so let's maybe do 100 and 100 here. Could save this, go back to the level, and if I would now in the level click the statue again and also select the move component here, you can see that the values have been propagated through to this panel. Move offset 100 and 100. And now as you can see, we basically have two ways of changing this. If I would maybe now go in and put this one to 0, save it, go back to the my statue, you're gonna see that this value has not changed because this is the default value. And this is also where this added everywhere comes in. If I would basically say edit defaults only, then you would just be able to modify this here. Then at the level, this would just not be visible. There would be nothing in here. You could not see this, you could not change it. You can only change this then on the defaults. Other way around, if you say edit instance only, you would not see this here at the defaults. You would just see this here at the instance panel. You can always revert at the instance panel to the default value by clicking on this reset arrow, and then basically it's gonna be resetted. Let's test it out, and we started and still doing the same, yeah, because we offsetted it by 100. If I would now click this again, go to the move component, reset it is, and start again, now it also moved in the other direction. It might not be 100% visible, so maybe let's make this a bit more extreme, maybe like something like 300. I would now start, yeah, there it is, moved somewhere. Let's keep these values, but let's now try to make this moving a bit more smarter, because currently we are just moving in one step. We are just moving to the end position, we are never going to move away from that. And that's what we want to change here in this tick event. So how am I going to do this? I want to add a few more parameters to that. I want to give it a speed, or actually not a few, I just want to add one. I want to give it a speed parameter. So how fast shall this move? Just going to move this to 1 unit at a second or at a tick. I'm not quite sure the delta time at the tick component. Let's actually see. Tick component UE5. Alright, so delta time is in seconds. I found it out. Yeah, it's nice. It's not standing in the official documentation, but yeah. So this is going to give us the information how many units per second we want to move. So let's put this one here as well. It's also added everywhere. So this is basically the offset to move. And this is our speed. And let's now maybe, how can we do this properly? So actually what I'm gonna have is I want to have a few more computed things. I want to have a new F vector, which is basically the move offset norm, which is a normalized vector, because I basically want to always move one at a second so that I can multiply this movement offset normalized basically by the current distance. And I'm gonna have a max distance in floating point, and I want to have a current distance in floating point. So you're gonna see in a second how this all comes together. So let's actually now go back to the constructor and let's compute normalized movement. So first of all, I want to set the move offset normalized to this one, and I want to actually normalize this. No, how does this work? fmath normalize. F vector normalize. Yeah, F vector normalize is the function that we are looking for, and it's the move offset that we're gonna plunk in there. Doesn't that work like that? Double tolerance, F vector 3D normalize double tolerance. So do we just use the move offset and call normalize on that? Does that work like that? Inline bool. Alright, yeah. Normalizing is then overriding the vector, so we first need to do this like that, and then call normalize. Like that? Yeah, that's how it works. Alright, so we just assign it to the move offset, and then we normalize it. So now we have a normalized vector of the offset. So basically now it's 1 unit of length, so that we can then basically apply this vector times the current distance. Now we just need to compute the maximum distance, and Visual Studio killed my cursor again. I love it. How do we do this? I just wanna, could restart this, but I'm not bothering now. Oh, there it is, back again. Interesting. Oh, they've maybe fixed, or is it just for this one? Can I reopen this to get my cursor back? Wrong file. Oh yeah, they fixed the bug. Yeah, Visual Studio fixed the bug in the last step. Clap, clap, clap. So max distance is gonna be equals to the move offset.length. Because I basically want to have a length of the vector. So I'm going to normalize so that I have a vector of the length 1, and I also want to have the total length of the vector, and then I can basically then I basically know how many times this normalized vector needs to be taken to get to where we want. So how do I get to the relative location? I'm going to take my start relative location. I'm going to take my move offset normalized, and I'm going to multiply this move offset normalized by the current distance, something like that, and then I basically should be at the correct position. Now I just need to basically set the current distance. And basically, how can I set the current distance? So let's first start very simple by basically first incrementing them. I'm going to increment the current distance by the delta time, because the delta time is in seconds, and I basically have the speed is basically the units per seconds that I want to move here, basically. And so I'm just basically going to add the delta time on top of that, and now it would move to infinity. Let's actually test this out, how it's moving to infinity. Go in here, recompile code. I was just very bothered on singing infinity here, but that's probably not what you want to hear. So there you go. Patched in. If I now would click start, the statue should move, but it's not. Why is it not moving? Oh, it is moving. It's just very slow. You can see. There it goes. But it's very slow. Let's of course, because I have a low speed. Let's now click on here and go back to my move component. Let's bump the speed up to 100 units per sec. Maybe a bit fast. 60 units per sec. There we go. Still slow? Oh yeah, because we don't consider our speed. That's important. That's interesting. Of course, we need to multiply the data time by the speed here. So if we don't do this, it's not gonna work. Compile it in again. And live coding succeeded. Good. Now it should move faster. Yeah, there it goes. You can see it is going away. No, statue, stay at our floor. Hey, come back. Where are you going? That's bad. Okay, so the statue is now going to infinity, as I already told you. But it is moving. That's good. Now let's make sure. I think it was still a bit too slow. I wanna get it fast, double the speed. All right. Now let's go back to C++, and we need to somehow move this. So currently we are moving in the plus direction, but that might not be good. We actually need to have a direction in which direction we're gonna move, and we're gonna have the move direction. The move direction is by default gonna be 1, because we're gonna move into the right direction. So how do we do this? We just multiply the move direction in. Now we just need to change the direction at some point. So basically what I want to check if current distance is bigger equal than max distance, or the current distance is smaller than 0, smaller equal than 0. So basically if we reached one of the extreme values, then I basically want to say move direction times equals -1, which is going to invert it. And this shall do the trick, actually. So let's see if this does the trick. Now we should basically just change direction as soon as we reach one extremity. And let's see if this what is going on here now. It is flying up, and it should change its direction now. Yeah, and now it's going back, and it's basically, come on, get away panel. And now we can actually see the table falls, and our statue shall move on the extreme values that we have specified with the current speed, which is currently 120 units per second. And as you can see, moving. That's nice. Doing exactly what we want. Yeah, that's a nice component. And it's actually quite modular, as you can see. We can always go in here and select a different position, like say, okay, we're gonna do 300, 300, or let's also actually say, yeah, we want to do 1200 and a speed of 500, something like that, and it's evaluating into the sky and going quite fast up and down. And the nice thing is actually that you can now apply this component to every actor you like. no matter what it is. If it is a player, of course apply it to him. If it is like the head of the player, I launch the head of the player in the air and up and down. Or you could do like something like the head that is slowly going up and down, boom, 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 something like that. Easy. Can always do this. Actually, that's it for today. I actually wanted to make this tutorial series not as long, but as you can see, we got quite far today, and it is quite detailed. That's okay to actually take this time. I hope you enjoyed the video, and I hope I'm gonna see you next time when we gonna tinker a bit more around. Actually, what I'm missing here is some visualization in the editor of the extreme points, because, well, I think we can actually go in and change the values here, but they are not really reflected in the editor. And I want to maybe draw some debug UI to do this. I'm not quite sure, I've never done this, but it's probably possible to do it. Right, we're gonna see. So we want to maybe draw some in-editor visualization of that, and I'm also gonna show you that we can tinker around with blueprints actually to control this all by blueprints. And that's actually the point there. Actually, can we do this? Yeah, at least the speed. We can actually at least set the speed. I mean, we're gonna do a few more things there. We're also gonna add a few functions to the stuff. You're gonna see. We're gonna think a bit more around with that component in the next video, make it a bit more fancy and a bit more usable. So yeah, thank you for watching. I'm gonna see you in the next video. Make sure to like and subscribe and hit the bell so that you get notified as soon as the next Unreal Engine video comes out, and you are thrilled to watch it, of course. So yeah, thank you for watching. Have a nice day and see you. Bye.